What if electricity could flow invisibly through the air, lighting up homes and powering machines without a single wire? This idea might sound like science fiction, but it was the dream of one of the most brilliant minds of the 20th century, Nikola Tesla. Today, we explore Tesla's groundbreaking attempts to create wireless energy transmission, focusing on his visionary Wardenclyffe Tower and the physics behind his ambitions. Along the way, we'll uncover some lesser-known details that make this story even more fascinating. Let's start with Tesla himself. Born in 1856 in what is now Croatia, Tesla was an inventor, engineer, and futurist who gave us revolutionary technologies like alternating current, AC, electricity. But Tesla didn't just stop at wires. He believed that the Earth itself could act as a giant electrical conductor, capable of transmitting energy wirelessly across great distances. To understand how, we need to dive into some physics. Tesla's vision relied on principles of electromagnetic waves. When electricity flows through a wire, it generates a magnetic field. Alternating this flow creates electromagnetic waves which can travel through the air. Radio, television, and Wi-Fi all use this principle. Tesla wanted to take it further, transmitting high-powered electrical energy wirelessly, not just signals. He aimed to create something akin to artificial lightning that could power entire cities. In 1899, Tesla conducted experiments in Colorado Springs to test his theories. Using a massive coil, known today as the Tesla coil, he generated electrical discharges that shot out like bolts of lightning, sometimes reaching over 40 feet long. More than a spectacle, these experiments demonstrated that high-frequency currents could travel wirelessly through the ground and air. Encouraged by these results, Tesla secured funding from industrialist J.P. Morgan in 1901 to build a facility on Long Island, New York. This became the Wardenclyffe Tower, a 187-foot structure with a massive copper dome. Tesla envisioned it as the first step toward a global network of wireless energy. He believed that by sending electrical energy into the Earth's crust, it could travel great distances and be tapped by receivers elsewhere. Imagine powering a light bulb in London from a generator in New York. No wires needed. The Wardenclyffe Tower was based on two key ideas. First, Tesla planned to use the Earth's natural electrical conductivity to create standing waves, oscillations that stay in place rather than moving outward like ripples on a pond. Second, he aimed to harness the ionosphere, a layer of Earth's atmosphere filled with charged particles, to amplify and distribute energy. However, translating theory into reality proved far more complex. The physics were uncharted, and the engineering challenges immense. Tesla faced skeptics who questioned the feasibility of his ideas, and even Morgan, his primary backer, eventually withdrew funding, believing Tesla's vision lacked commercial potential. The tower was dismantled in 1917, marking the end of Tesla's grand experiment. Despite this setback, the underlying science of wireless energy remains compelling. In recent years, researchers have revisited Tesla's ideas with modern technology. For instance, wireless charging pads for phones use inductive coupling, a principle similar to Tesla's experiments. Engineers are also exploring wireless power transfer over longer distances using lasers and microwaves, though challenges like energy loss and safety remain. Tesla's work with the Wardenclyffe Tower also inspired concepts in sustainable energy. He imagined a world where renewable sources like solar and wind could generate electricity distributed wirelessly to areas in need. While we haven't achieved this yet, Tesla's vision aligns with today's push for cleaner, decentralized energy systems. One lesser-known aspect of Tesla's Wardenclyffe project is how it intersected with his other interests. Tesla was fascinated by resonance, the idea that objects vibrate at specific frequencies. He once claimed that by tuning into these natural frequencies, he could even affect the structural integrity of buildings. This led to legends, including an unproven tale of Tesla accidentally causing a small earthquake in New York during a resonance experiment. While these stories are often exaggerated, they highlight Tesla's ability to think far beyond conventional boundaries. Another intriguing detail is Tesla's belief in the ethical use of technology. He envisioned his wireless energy system as a way to provide free, unlimited power to humanity, breaking the grip of monopolies and fostering equality. However, this idealism clashed with the profit-driven motives of his time. The idea of free energy didn't sit well with investors, and Tesla struggled to secure the financial support needed to bring his dreams to life. As we reflect on Tesla's legacy, it's clear that he was ahead of his time in many ways. The Wardenclyffe Tower may have failed, but it planted seeds for future innovations. Tesla's daring experiments paved the way for modern wireless communication and energy research, proving that even ambitious ideas can spark progress. In the end, Tesla's story reminds us of the power of vision. He dared to imagine a world transformed by technology, not for profit, but for the benefit of all. Today, as we face challenges like climate change and energy inequality, Tesla's dream of wireless energy feels more relevant than ever. Perhaps the next breakthrough will come from someone inspired by the man who tried to harness artificial lightning to change the world. So, as you look at the devices around you, from your smartphone to your Wi-Fi router, remember Nikola Tesla. His ideas helped shape the technology we often take for granted. And who knows, the next time you hear thunder or see a flash of lightning, you might just think of the man who dreamed of taming that power for the good of humanity.